Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Khairatul Athirah binti Mohammad suhaimi from RK23 Group 2 and my ID's numbers is 1910910993. So today I will present for you three-phase parameter which is our project. So the next one is for the introduction. So first of all is introduction. So introduction for three-phase system. Three-phase system is when the current pass through the three wires and there will be neutral wire passing the fault current to the earth. So three-phase system is system which is use three wire for generate, transmission and distribution. There are two type of connection in three-phase, which is star connection and delta connection. First one, for star connection it required four wires and commonly used for long distance transmission because it has neutral wire. The neutral point passes through unbalanced current to the earth and make the system balanced. For delta connection, it has three wires and there is no neutral point. The line voltage is equal to phase voltage for delta connection. Lastly, in this project, we use 2 wattmeter method to figure the power delivered by the three-phase system. Wattmeter can be connected to measure power in each phase to obtain the real power. So the next one is the objective of this project. So first one, ability to evaluate the parameter of a three-phase system. Which one is the voltage, phase voltage, line voltage, load voltage, load voltage. So the next one is be able to calculate the voltage and current for a three-phase star or delta connection, generator or load. I have shown that in my report. So the last one is understand how to calculate or know how to calculate the real, reactive and apparent power to all the element of star or delta connection, load and the power to the load. So the next one is the methodology. So first of all, I use PSIM in these projects. So I construct this circuit, the three-phase circuit, which is Y generator to Y load. So Y to Y. In this in PSIM software. So this one is phase voltage at the generator and this one is phase voltage at the load. So this one is I line and this one is also I line. IAA, IBB and ICC. So so first of all I determine the phase voltage at the generator. So we were given line voltage. So as we know, the Y to Y Y to Y connection. So the V line is the V phase at the generator is equals to square root 3 to V line. So we will get the 158.77 phase voltage. So the next one, we will measure the VAN, VVN, and the VCN here, and IAA, IBB, and ICC. So I will determine this all the unknown. So the next one is circuit with wattmeter. So as we know wattmeter, we will add the ammeter and voltmeter in one square, which is here. This one and this one. That's why we call it 2 wattmeter because there are 2 wattmeter. So in this circuit, we will calculate and measure the IA wattmeter, ICC wattmeter, EAB wattmeter, and EBC wattmeter. So the next one is result and discussion. So here I will show you the circuit that I made in PSIM. So if you want to, first of all, we want to find the resistor, inductor, ammeter, voltage source. So we will have it down here. So we will just choose or we will find it here. For resistor, inductor, capacitor. So we will type here so we can find what things that we want. So first of all, so in this circuit, so I want to find the line current, line IAA, which is IAA, IBB and ICC, because VLAN had already given to us. So V phase in generator also have. So we want to find the VAN, VBN and VCN. So uh, first of all, we need to put the simulation control. We set the total time is to 0.1. And then, before I forget, the VAN, the frequency is 50 because the load phase is 0, so it will lagging 30 degree. So we run the simulation and then okay. So what did I want to measure? So IAA, IBB and ITC. So I will show you one by one. So I will add this. Okay. And it will show you this graph. And then you measure. So you measure. Then it will go out with like this. So right here. So we get here is ICC. So you will get 8.58328. It's same with what I calculate as I show you in my report, which is this one. Okay. 858.32. It's same. Okay. Next one is so IAA is also same. IBB also same. 8.5832. So the next one is phase voltage. VAN, VBN and VCN. So we add this one is remove, add. Okay. So the VAN we will get 7.88487 as shown as I calculated, which is also same. This one? Okay. 78.487. Okay. The load voltage, phase load voltage will be same because this one, the impedance is same. This one is 91, this one is also 91, this one 91, and the inductance also same. So the next one is 2 meter method. So for 2 wattmeter method, as you can see, I put here IAA wattmeter, EAB wattmeter as 1 wattmeter. So that there are 2 wattmeter in this circuit. That's why we will call it 2 wattmeter method. All the things are same, but we add here EAB wattmeter and ECB wattmeter. So in this, we will measure the EAB and IAB. So here we add EAB wattmeter, ECB wattmeter. We add that. Okay. So we will get ECB wattmeter 1.3594, which is same that I calculated. Wow, where? This one. 135.943. This one also. Okay. As I shown before, so I calculate the EAB and ECB wattmeter, right? So the next one is IAA wattmeter and ICC wattmeter. As we know, 2 wattmeter method is used for measure to calculate our power in this 3-phase system. So this one, then we wait wait one, we will measure, simulate, run simulation, and then okay, we will add the IAA wattmeter and ICC wattmeter. And okay, so we will get this graph, and then we will calculate. So for ICC wattmeter, okay, we will get 8.5832, which is same with ICC without wattmeter. It's same with line current, and I also same with IA wattmeter, and I already shown my calculation in my report. So 8.58328. Okay. Okay, that's all for simulation. So I will proceed with my discussion. So for discussion, okay, all the line current is same, with or without wattmeter, because all the load is same, which is 91 and plus 9J ohm. So theoretically, phase current and line currents to supposed to be equal, because three-phase circuit is Y connected generator with a Y connected load. So first of all, I have shown you how to find the phase voltage, right? So V line is square root 3 times phase voltage. So for power, the voltage across the load impedance and the current in the impedance can be used to compute the power per phase. For active power, total active power is time with power of one phase. So, as I shown you before, in this project, 2 wattmeter method was used to measure the total power. A wattmeter can be considered as voltmeter and ammeter in the same box, like this one. One box. This one is one box, so 2 box for 2 wattmeter. So in balance load, the sum of the wattmeter reading give the total power. I show you in my calculation. This one. Wattmeter 1, so I get 1. Wattmeter 2, I get 1 power. Okay. So the last one is for the conclusion. So as conclusion, in this three-phase system, will have better and higher efficiency compared to single-phase system. In single-phase system, limited amount of power can be transported. The three-phase system can be used as three single-phase line, so it can act as three-phase system. These three-phase systems are considered as a balanced circuit made up by balanced three-phase sources, a balanced line, and balanced load. So Y-to-Y connection is required in three-phase to simplify the circuit and ease the analysis. Three-phase circuit is also weight less than single-phase circuit of the same power rating. Next, the system has wide range of voltage. Three-phase equipment is smaller in size, weight less, and more efficiency. So lastly, the the objective in this project is achieved. Thank you. That's all from me. Assalamualaikum.